In this video, I'm going to demonstrate how to do a derivation of derivation 2.6 LRS 202. So we'll start off with show conclusion, and we'll pop in our premises. And we can't do anything. Oh, I skipped something. We should always check. Can we make an assumption? No, because we're trying to show biconditional, so we can't apply assume CD. Okay, therefore, we put in our two premises, and then we're stuck. So when you're stuck, you're going to do a subderivation, so we need to decide what do we want to do a subderivation of. We want to do a subderivation so we say we're stuck, so do a subderivation of what will help complete the derivation. And how do we complete a derivation? By boxing and canceling. So really, what will help box and cancel? Okay, so what's going to help us box and cancel this derivation? Well, we have two ways of boxing and canceling the derivations in general, direct and conditional. We can't use conditional because we're not trying to show a conditional, we're trying to show a biconditional. So it's going to have to be box and cancel with direct derivation. So we're going to need to get, so what we want in the end is Q if and only if P, because then we'll apply DD, and we'll be done. So how do we get Q if and only if P? Well, if we remember in the previous derivation, we looked at, it was a conjunction of two conditionals. So we said, how do we get the conjunction of two conditionals? Get the two conditionals, apply ADJ. Here we say I have a biconditional. How do I get a biconditional? Well, I get the two conditionals that are inside of it and apply CB. So what I want then is if Q then P and if P then Q. And if I can get those two, then, right, I can apply, oops, fingers are all over the place. If I can apply CB to these two, and we get Q if and only if P, right? That's how we build biconditionals. You get the two component conditionals. So that's what we want. We want to get if Q then P and if P then Q, and then apply CB, and we're done. Because we'll have what we need for DD. So if we look up here, we say, well, what do we have? Do we have either of these two? And in fact, we do. We already have if Q then P. This one we have. So all we need to do is get if P then Q, and then we'll apply CB, and we'll be done. Sounds good. Now, there's a little show command that will actually help us with that. So right now we're trying to show a conditional, right? And so what we want to do to get the, we're trying to show a biconditional. So what we want to do is get the two conditionals that make it up and then apply CB. So we can say show COND for show conditional. That's a part of the biconditional. So we say show COND, and it's going to ask us which of the two conditionals do we want to show. Well, we already have if Q then P, and we want if Q then P and if P then Q, so we want to choose if P then Q, and the program writes it in for us. Very nice. Okay? Nice little shortcut. So we have it. We're trying to show if P then Q because we'll put, when we're done with line 4, when we box and cancel it, we'll put it together with line 3 to create if Q if and only if P, which we will then use to box and cancel with direct derivation. So we're trying to show if P then Q. Well, we're trying to show a conditional. Whenever you're trying to show a conditional, you should make a conditional assumption, so we get P. And now we want to say, well, can we do anything with P? Can we use P? Well, can we use P with line 3? No, we can't. 3 is if Q then P, and P is its consequent. Nothing to be done there. What about with line 2? Well, on line 2, I can't do modus ponens with it, and I can't do MT either, because for MT, I need the negation of the consequent, and that's negation P, which is not line 5, which is just P by itself. But we can apply DN, we get negation P, and now we can put that together with line 2 for modus tollens. Get negation Q. Well, I'll just take those negations off, and there is the consequent of the line 4, which we were trying to show. So, good. Now we're basically done, because we can put 3 and 4 together using the rule CB, and we will get the conclusion, and we can apply direct derivation to line 10 to complete the derivation. So again, we're trying to show this biconditional. To show a biconditional, we need to actually get the biconditional and apply direct derivation. To get the biconditional on a line, we have to use the rule CB, because that's the rule that produces biconditionals, and it produces biconditionals from the conditionals going in each direction. So we wanted the conditional going from Q to P, and the conditional going from P to Q. That's all reasoning you can do. It's what do I want? I want to box and cancel. How am I going to box and cancel? With direct derivation. What do I need? That means I need to get this. What do I need to get it? Well, what's the rule? And what do I need to apply the rule to, right? So it's, you know, how do I box and cancel? What do I need to box and cancel? Whoops. How can I, what rule? How can I get what I need to box and cancel, and specifically what rule? And then what do I apply that rule to? So how do I box and cancel? It's going to be direct derivation, because we can't do CD because we're not trying to show a conditional. So what does that mean? What do you need to box and cancel? Q if and only if P, because that's the conclusion. How can I get what I need to box and cancel? What rule? The rule CB. That's what produces biconditionals. And what do I apply that rule to? If P then Q, and if Q then P. And that tells us, okay, these are the things we want to get in order to complete the derivation. Once we have them, we can use CB to build this to apply direct derivation. So then we go and look and we say, oh, we already have one. Let's show the other. We do. We apply CB, we apply DD, and we're done. So that's an example of doing a biconditional derivation. We'll look at another example from the homework in the next video.